arithmetic progression. Let us understand what is a sequence. For this, we have to take some arrangement or series of numbers. 1, 3, 6, 9, 12, and so on. 2, 2, 4, 8, 16, and so on. 3, 1, 1 by 2, 1 by 3, 1 by 4, and so on. 4, 3, 10, 6, 5, and so on. In the first example, which is a table of 3, let us see what is the relation between the numbers and their corresponding places. 3 equals 3 into place number equals 3 into 1. 6 equals 3 into place number equals 3 into 2. 9 equals 3 into place number equals 3 into 3. 12 equals 3 into place number equals 3 into 4, and so on. Therefore, the number in the nth place will be 3 into n. The second example, that is 2, 4, 8, 16, and so on, can be written as 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on. Therefore, the number in the nth place will be 2 to the power of n. The third example, 1, 1 by 2, 1 by 3, 1 by 4, and so on, can be written as 1 upon 1, 1 upon 2, 1 upon 3, 1 upon 4, and so on till 1 upon n. The relation is 1 upon place number. But in the fourth example, we do not find any such relation. In the first three examples, we observe a specific arrangement of numbers. Such an arrangement is called an ordered arrangement. Now we can understand what is a sequence. An ordered arrangement of real numbers is called a sequence. In the sequence 2, 4, 6, and so on till 2n, the numbers in the sequence are called the first term, the second term, the third term, and so on till the nth term. These are denoted by T1, T2, T3, and so on till Tn. Here T1 equals 2, T2 equals 4, T3 equals 6, Tn equals 2n, and the sequence is denoted by sequence 2n. Remember, in general, a sequence is expressed by its nth term enclosed in curly brackets as Tn and read as sequence Tn. What is arithmetic progression? AP. For a sequence Tn, if the difference between the consecutive terms, that is Tn plus 1 minus Tn, for every n which belongs to n is constant, then the sequence Tn is called an arithmetic progression, or AP. The constant difference is called the common difference and is denoted by D. That is, Tn plus 1 minus Tn equals T, T2 minus T1 equals T, T3 minus T2 equals T, and so on. Let us look at an example. 3, 6, 9, 12. Here 6 minus 3 equals 3, 9 minus 6 equals 3, 12 minus 9 equals 3. So the common difference is constant. Therefore the sequence is an arithmetic progression, and b equals 3. The general term or the nth term of AP. Let us consider an AP with the first term a and the common difference d. Then this AP is given by a plus d, a plus 2d, a plus 3d, and so on. Clearly, in this AP, we have the first term equals T1 equals a plus 0d equals a plus 1 minus 1 into d. The second term equals T2 equals a plus d equals a plus 2 minus 1 into d. The third term equals T3 equals a plus 2d equals a plus 3 minus 1 d. The fourth term equals T4 equals a plus 3d equals a plus 4 minus 1 d. The nth term equals Tn equals a plus n minus 1 into d. That is, the nth term equals the first term plus n minus 1 into the common difference. So Tn equals a plus n minus 1 into d. Remember, to write the terms of an AP, we require the first term and the common difference. Let us look at some examples on the above topic. 1. Find out which of the following sequences are arithmetic progressions. If the sequence is an AP, find the common difference and write the next two terms. 1. 2, 6, 10, 14. Let A equals T1 equals 2, T2 equals 6, T3 equals 10, and T4 equals 14. T2 minus T1 equals 6 minus 2 equals 4. T3 minus T2 equals 10 minus 6 equals 4. And T4 minus T3 equals 14 minus 10 equals 4. Here the common difference equals D equals 4, and it is constant. Therefore, the given sequence is an AP. T5 equals A plus 5 minus 1 into D equals 2 plus 4 into 4 equals 2 plus 16 equals 18. T6 equals A plus 6 minus 1 into D equals 2 plus 5 into 4 equals 2 plus 20 equals 22. Therefore, the sequence equals 2, 6, 10, 14, 18, 22. 2, 24, 21, 18, 15. Let A equals T1 equals 24, T2 equals 21, T3 equals 18, and T4 equals 15. T2 minus T1 equals 21 minus 24 equals minus 3. T3 minus T2 equals 18 minus 21 equals minus 3. And T4 minus T3 equals 15 minus 18 equals minus 3. Here, the common difference equals D equals minus 3, which is constant. Therefore, the given sequence is an arithmetic progression. T5 equals A plus 5 minus 1 into D equals 24 plus 4 into minus 3 equals 24 minus 12 equals 12. T6 equals A plus 6 minus 1 into D equals 24 plus 5 into minus 3 equals 24 minus 15 equals 9. Therefore, the arithmetic progression is 24, 21, 18, 15, 12, 9. 3. Which term of the arithmetic progression 8, 11, 14, 17, and so on is 758? A equals 8, T equals 11 minus 8 equals 3, and Tn equals 758. We have to find the value of n. Tn equals A plus n minus 1 into D. Therefore, 758 equals 8 plus n minus 1 into 3. Therefore, 758 minus 8 equals n minus 1 into 3. Therefore, 750 equals n minus 1 into 3. Therefore, 750 upon 3 equals n minus 1. Therefore, 250 equals n minus 1. Therefore, n equals 250 plus 1. So, n equals 251. Therefore, the 251st term of the given AP is 758. Example. For an arithmetic progression, if T4 equals 20 and T7 equals 32, find A, D, and Tn. We know that the nth term of any arithmetic progression Tn equals A plus n minus 1 into D. T4 equals A plus 4 minus 1 into D. So T4 equals A plus 3D. But T4 equals 20. This is given. Therefore, A plus 3D equals 20. Equation 1. T7 equals A plus n minus 1 into D. T7 equals A plus 7 minus 1 into D. T7 equals A plus 6D. But T7 is given as 32. So 32 equals A plus 6D. Therefore A plus 6D equals 32. Equation 2. Equation 1 minus equation 2. A plus 3D equals 20 minus A plus 6D equals 32 implies that minus 3D equals minus 12, so D equals 4. Put D equals 4 in equation 1. A plus 3D equals 20, therefore A plus 3 into 4 equals 20, therefore A plus 12 equals 20, therefore A equals 20 minus 12 equals 8. The sum of the first n terms of an arithmetic progression. You know about Carl Friedrich Gauss. Carl Friedrich Gauss was a German genius. When he was very young, his teacher asked the children of his class to add the numbers from 1 to 100. Do you know, he gave the answer within a few seconds. He used the arithmetic progression to do this. Let us see how. Let S equals 1 plus 2 plus 3 plus 4 and so on plus 98 plus 99 plus 100. This can be written as S equals 100 plus 99 plus 98 and so on plus 4 plus 3 plus 2 plus 1. Adding the corresponding terms. 2S equals 100 plus 1 plus 99 plus 2 plus 98 plus 3 plus 97 plus 4 and so on plus 97 plus 4 plus 98 plus 3 plus 99 plus 2 plus 100 plus 1. So 2S equals 101 plus 101 plus 101 plus 101 and so on plus 101 plus 101 plus 101 plus 101. This is done 100 times. 2S equals 100 into 101. So 2S equals 10,100. Therefore S equals 5,050. Now we can use the Gauss technique to find the sum of the first n terms of an arithmetic progression. The sum of the first n terms of an arithmetic progression is denoted by Sn. If the first term equals A and the common difference equals D, then AP equals A1, A plus D, A plus 2D and so on till A plus n minus 1 into D. Pn equals A plus n minus 1 into D. N belongs to n. Let Tn be denoted by L. Then the first n terms of the AP equals A plus D, A plus 2D and so on till L minus 2D, L plus D, L. Therefore, the sum of the first n terms of the AP is given by Sn equals A plus D plus A plus 2D and so on till L minus 2D plus L minus D plus L. Also, Sn equals L plus L minus D plus L minus 2D and so on plus A plus 2D plus A plus D plus 8. Adding the corresponding terms of the equations, we get Sn plus Sn equals A plus L plus A plus D plus L minus D plus A plus 2D plus L minus 2D and so on plus L minus 2D plus A plus 2D plus L minus A plus A plus D plus A plus L. So 2Sn equals A plus L plus A plus 6 plus A plus L and so on plus A plus L plus A plus L plus A plus L n times. Therefore 2Sn equals n into A plus L. Therefore Sn equals n upon 2 into A plus L. Therefore Sn equals n upon 2 into T1 plus Tn. Since T1 equals A and L equals Tn, put T1 equals A and Tn equals a plus n minus 1 into d, then Sn equals n upon 2 within brackets a plus n minus 1 into d, then Sn equals n upon 2 within brackets a plus n minus 1 into d. Therefore, Sn equals n upon 2 within brackets 2a plus n minus 1 into d.